Normal distribution is something which occurs quite frequently in nature. It resembles a distribution where most of a data set lies close to the center, where the average or the mean is. Fewer amounts of data are either a lot higher or a lot lower than the mean. An example where this occurs in nature is male height. When plotted, the normal distribution curve is smooth, bell-shaped, and symmetrical, meaning it has the same amount of data set on each side of the mean. In this curve, the mean, represented by the Greek letter mu, is in the center, where most of the data lies. We write 0 for this position because we're going to compare the mean to other values that may be bigger or smaller than the mean. So each of the other numbers below this curve resemble the number of standard deviations they are from the mean. Standard deviation is just a number which shows how far apart the data is spread from the mean. So it shows whether the curve is going to be wide or narrow. For example, where it says 1, it represents the value which is 1 standard deviation above the mean. Similarly, -1 represents 1 standard deviation below the mean. The empirical rule states that 68% of data lies within 1 standard deviation of the mean. So this is 1 standard deviation below the mean and 1 standard deviation above the mean, and all the data that lies between it is 68% of the data. Similarly, approximately 95% of the data lies within 2 standard deviations of the mean, and 99.7% within 3 standard deviations of the mean. Now, the system for placing the numbers in the way we have, where mean is 0 and all other numbers represent the number of standard deviations above or below the mean, is called the z-score. This is important because you may be a fraction of standard deviation away from the mean, for example 1.5 standard deviations from the mean, in which case you would say z is equal to 1.5. The formula for z-score is z is equal to x, which is the data point you want to know the z value for, minus the mean, all of this divided by sigma, which is the standard deviation. So to put all of this into practice, here's a question. The mean and the standard deviation of a physics and chemistry test are shown below. The marks for both are normally distributed. So we can see the mean for physics is 54, with the standard deviation being 6. And for chemistry, the mean is 62 and standard deviation is 8. Florence scores 66 in the physics test and 74 in the chemistry test, but she claims that she's better at physics than at chemistry. By standardizing her marks, find out whether her test results support her claim. Okay, so here I've drawn out the normal curves for both subjects to show you what they look like when they're graphed. And now we'll solve the question. So for physics, we can see that the mean is 54, so 54 would be around here, and that's where the center is. So this would be represented as 0 on our z-score. And the standard deviation is 6, so 54 plus 6 would be 60. So this would be around here, so 1 standard deviation above. But we don't need that at the moment, that's just to point it out. And 62 is the mean for chemistry, so 60 is here, 62 is about here. So our 0 value for the z-scores is around here. And if you add 8 to that, 70, this would be the first standard deviation. So 68% of data would lie between here, and for this between here and here. So we're going to use our z-score formula So we have Z is equal to X minus the mean all over the standard deviation. In this case, for the physics, X is equal to 66. The mean is 54. And the standard deviation in this case is 6. 66 minus 54 gives you 12. This divided by 6 gives you 2. So this is for physics, and for chemistry we'll do the same thing. X minus mu all over sigma is equal to, in this case she got 74, so we have 74 minus 62 all over standard deviation, which is 8. So 74 minus 62 also gives us 12. So we have 12 over 8, which is equal to 1.5. So here we had drawn out one standard deviation away from the mean. If we were 2 standard deviations, we'd be about here. And if we were, so this is the case for physics, and the case for chemistry, she's 1.5 standard deviations, so about there. So as we can see from this example, from physics, she's better than all of these people, and for chemistry, she's better than all of these people. So in the case of physics, there's more people that she's better than physics at from her class, as opposed to chemistry. So her claim that she's better at physics than chemistry is true.